Hi students, hope you understood yesterday's concepts very nicely, and today we are continuing the session with ratios and identities concepts with some examples. But before going into that one, we need some algebra formulae, and these algebra formulae many times in our JEE mains level, advanced level problems we require, so that we should know about what are main important algebra formulae which we need many times in our coming problems. Let us start with algebra formulae. A square minus b square equal to a minus b into a plus b. Many of you well about this formula. Now any time whenever you by heart or whatever you learn these formulae in school level or any time, but don't understand these are measured only for A and B. These are not meant only for A and B. Once you are giving a formula, the meaning is this formula is applicable for any real number. So now here while using this formula many times students they understand, okay, this is a formula, that's it. But don't think this is just a formula. This formula whatever they are going to derive, those are for applications of in real numbers. Now let us take here suppose a right angle triangle. You know about this hypotenuse given as 65 and this adjacent side given as 63. Now the question is, what about this opposite side? Of course many of you are aware of some of these triplets, but sometimes some values you got in this way, then immediately what is our formula? Pythagoras formula. From Pythagoras formula we write, suppose this is our x, then x square we write as 65 square minus 63 square using our Pythagoras formula. Now from Pythagoras formula once you write this way, then immediately you want to take 65 into 65 and after that 63 into 63 and you want to calculate and thereby you want to subtract. After the subtraction again you have to take square root, but this is a lengthy procedure. In that way you can make use of simply this formula. Thereby I can write this one as 65 plus 63 and into this is 65 minus 63. So that what about this value here? This is equal to 65 plus 63 if I write, then this is 8 here and this one is 128. And after that this value is 2 and you know this is 256 which is nothing but 16 square, and hence directly you can write this value as how much here? 16. So this is the advantage of the formula a square minus b square. So in numbers whenever you observe real numbers, these type of values just make use of this formula. Not only for right angle triangle or this time, and you can make use of, suppose I write 35 square minus 21 square, understand? Then whenever it is 35 square minus 21 square, here no need of writing 35 plus 21 in the beginning itself in this way. Here there is no common factor from these two numbers, whereas here there is a common factor and you know the common factor is nothing but 7 here, 7 here. And therefore I am writing here 7 square into 5 square minus 7 square into 3 square. And now you take 7 square common, thereby it is 5 square minus 3 square. And now this is 7 square, now you can make use here 5 plus 3 into 5 minus 3. Thereby it is 49 and into this is 8 and this one is into 2. And hence you got the value as 49 into 16. And hence the value you can say the value 49 into 16 you can calculate very easily. So like this you have to make use of the formula a square minus b square is a minus b into a plus b in our further calculations. Now the next formula is, if I write a plus b whole square plus a minus b whole square, this is equal to 2 times of a square plus b square. And this you know very well about a plus b whole square formula, a square plus b square plus 2ab, a square plus b square minus 2ab, and then plus 2ab minus 2ab cancel, 2a square terms present, 2b square terms present. So directly you can write in this way, what is the use of this formula again? Suppose I got sin theta plus cos theta whole square and plus sin theta minus cos theta whole square, then no need of again solving, that is sin square plus cos square plus 2 sin cos etc. Directly you write it as 2 times sin square theta plus cos square theta, and thereby your answer is nothing but how much? 2. So in this way just make use of this kind of formulae. And next one is, if I take minus symbol, that is a plus b whole square minus a minus b whole square, then this is equal to 4 times ab. Again suppose if I got a as secant theta and this one as plus, this is b means it is tan theta and whole square minus secant theta minus tan theta whole square, then what is the meaning here? This is equal to 4 times, directly you can write secant theta into tan theta, directly you can evaluate in this way. And next one it is, if I take suppose a plus b as tan and cot, tan theta plus cot theta whole square, and next value minus tan theta minus cot theta whole square. Suppose a problem is given in this way, then directly you can write this value as 4 times tan theta into cot theta, and previous session we have observed tan theta into cot theta as 1, so that this value is nothing but how much? 4. That's why these type of formulae please don't ignore, and in problems whenever you come across like this, directly you can make use of this one. Next formula is a plus b whole cube. A plus b whole cube, in this formula we write a cube plus b cube plus 3a square b plus 3ab square. This formula all of you know, very familiar. Now the same formula I can write a cube plus b cube plus 3ab if you take common, this is into a plus b. Got the point? And this is a plus b whole cube. And from this formula I will write even a cube plus b cube equal to this a cube plus b cube equal to a plus b into, or you can write a plus b whole cube minus 3ab and into a plus b also. So this one also you can make use of from this formula a cube plus b cube, take this entire term this side and thereby I can write in this way. What is the advantage if I write in this way? Sometimes they ask about what is sin power 6 theta plus cos to the power of 6 theta. Then all of you know very well, I can write this as sin square theta whole cube plus cos square theta whole cube. Then immediately you will get a doubt, why not it is sin cube theta whole square plus cos cube theta whole square? I wrote this one comfortably. The reason is, here sin square theta plus cos square theta value is 1. That is the reason I want to write in this way instead of sin cube theta whole square plus cos cube theta whole square. So now this is of the form A and this one is B. So A cube plus B cube. So what is this value? It is sin square theta plus cos square theta whole cube, and next one it is minus 3 sin square theta cos square theta and into sin square theta plus cos square theta. So that what is happening? This is 1 and this one also 1. So you got 1 minus 3 sin square theta cos square theta. This is the advantage of making use of this formula. The same formula again you can write after simplification a plus b. I am taking common, and if you do simplification a square minus ab plus b square also. So a cube plus b cube even you can write in this way also. Sometimes this also useful, sometimes this one is useful. So whenever formulae are coming plenty, then don't here misunderstand that how can I use these many formulae. That's why in mathematics any faculty they used to say practice is very important. If you do practice of all problems, then you can understand which formula perfectly where it can match. And next one, suppose if you take a cube minus b cube, and this one is one of the formula you can apply, a minus b into a cube plus ab, a square plus ab plus b square. So this is another formula, that is for a cube minus b cube. So these are main important formulae which you can apply for any type of real numbers. And now suppose if I write another formula, that is a plus b plus ab plus 1. This also many times it comes in trigonometry or many other applications. So this formula I can use it as 1 plus a into 1 plus b directly. Suppose you will get 1 plus tan a plus tan b plus tan a tan b, then the answer they give as a product of two terms. When the answer is product of two terms, nothing to worry, you know about this formula. Instead of taking common, simplifying everything, directly you can write it as 1 plus tan a into 1 plus tan b directly. Got the point? So here you observe a plus b plus ab plus 1. And suppose if I write a minus b minus ab plus 1, then also you just observe one thing, that is what I did here, I just replaced b value as how much here, minus b, that is the only thing. So there the magic you observe, 1 plus a into this is 1 minus b, directly you can write. So the formula, nothing to worry about it, not a new formula, it is the known one only, just we replaced b by how much here, minus b. So in the answer also I just replaced b as how much here, minus b. So students, these are some of the important formulae. Not only this, you can use the other formula. This is a very important formula in algebra, not only in trigonometry but in other chapters also. That is a cube plus b cube plus c cube equal to 3abc. All of you know about this equation. The meaning is, this is whole good or this whole good implies and implied by a plus b plus c equal to 0 or a equal to b equal to c. So whenever you got this kind of equation in problems, then the condition is either a plus b plus c 0 or a equal to b equal to c. Again, what is the value of this one? So that is a cube plus b cube plus c cube minus 3abc. This is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. This is the formula for a cube plus b cube plus c cube minus 3abc. Now you observe, from this formula, if this value is equal to 0, that means a cube plus b cube plus c cube equal to 3abc. If this value equal to 0, either this is 0 or this factor is 0. That implies a plus b plus c is 0 and this value is 0 only when the three terms are equal. That means a square plus b square plus c square minus ab minus bc minus ca always greater than or equal to 0. Always means what is the meaning? Not yesterday, today, tomorrow. Always means for every real number. For every real number a, b, c, this is true. And strictly greater than 0 is applicable. Strictly greater than 0 applicable when a comma b comma c real numbers which are distinct, when these are all different, distinct numbers, and this is equal to 0 when a comma b comma c are equal, that is a equal to b equal to c. So in this way, these all formulae whatever we wrote till now, these are very important in our coming chapters, not only trigonometry but in other chapters also. So students, be confident with these formulae, wherever necessary directly you can make use of them. Secondly, so students, yesterday we have observed some identities. Let us continue. Why I interrupted with these algebra formulae? Because in all these coming identities, those formulae are necessary. That's why. So let us start with cos to the power of 4 theta plus sin to the power of 4 theta. Cos power 4 theta plus sin power 4 theta. Whenever I am writing this value, you understand theta is any real number, because cos is there, sin is there. Yesterday we have observed that this theta is applicable for any kind of real number. Now, this is cos power 4 plus sin power 4. We know about cos square theta plus sin square theta is 1. So that I can write this value as cos square theta plus sin square theta whole square minus 2 times sin square theta into cos square theta. So this one is a square plus b square whole square minus 2ab. So we applied which formula, students? This is a power 4 plus b power 4 is a square whole square plus b square whole square, and hence this is a square plus b square whole square minus 2 times a square b square. So in this way I use this formula algebra for this term. Now cos square plus sin square, it is 1. So this is minus 2 sin square theta cos square theta. So the formula you got now, cos power 4 plus sin power 4 theta equal to this one. One of the important formula in trigonometry. So whenever we are taking any formula, these are not confined to this particular chapter only. These will come in our future chapters also. For example, if I take a problem of integral of cos to the power of 4 theta plus sin to the power of 4 theta divided by, they will ask about cos theta plus sin theta d theta. At that time, directly we apply this formula in numerator, and thereby we can complete the integration process. So that is the reason trigonometry, why we start in the beginning. The meaning is here, every time in other chapters frequently we apply. And next one, cos to the power of 6 theta plus sin to the power of 6 theta equal to 1 minus 3 sin square theta cos square theta. This formula already I explained you while solving a cube plus b cube value. Okay. So now you observe how to remember these two particular formulae. It's very easy dear. How to remember means 4 here, exactly half the value present. 6 here, exactly half the value here. Both are similar kind, 1 minus, sin square cos square, sin square cos square. Only thing, here 2, here 3, the 2 is exactly half of this value and this 3 is exactly half of this value. That doesn't mean, don't understand, don't generalize, cos to the power of 8 plus sin to the power of 8. Ma'am, we can take this formula also, because you only said half of the values you are getting. So no such values, understand? So only for these two I am telling about the hint, that is 4 half the value, 6 half the value, but this is not true. Okay. So this is another identity you can take, cos power 4 plus sin power 4, cos power 6 plus sin power 6, a very important. That's why I kept in boxes which are very important. Jewels you can take, right? Next, another identity. Yesterday we have observed secant square theta minus tan square theta equal to 1, where theta will take all the real numbers except odd multiples of pi by 2. Now from this one, you know this is a square minus b square equal to 1. So I can write this as secant theta minus tan theta and into secant theta plus tan theta equal to 1. So that you can write this value as secant theta minus tan theta equal to 1 divided by secant theta plus tan theta and vice versa. That means secant theta plus tan theta equal to 1 divided by secant theta minus tan theta also. Just a small development from this already known identity. For example, how they used to ask this type of examples. Suppose if they give secant theta minus tan theta equal to 3, okay, this is given. Then the question they will ask about in which quadrant theta lies. In which quadrant? They are not asking about what is the value of theta. They are asking about in which quadrant this theta lies. What is the quadrant? Is it first quadrant, second quadrant or third quadrant? So in which quadrant theta lies? Then you don't know anything. You have only one equation in hand, and secant theta minus tan theta equal to 3. That is the only weapon you are having. Then how to solve in which quadrant theta lies? Then at that stage we apply this one. That is secant theta minus tan theta equal to 3 implies you can take secant theta plus tan theta is how much here? 1 by 3. And thereby if I add these two values, then 2 secant theta equal to 3 plus 1 by 3. That implies secant theta equal to, it is 9 plus 1, 10 divided by 6. So I have taken LCM 9 plus 1, 10 by 3, and this 2 goes down, thereby you got 10 by 6. That means this is equal to 5 divided by 3. Now you got secant theta 5 by 3. Immediately don't come to the conclusion as secant is positive, therefore obviously theta is acute angle, so first quadrant. Previous session we have observed secant theta positive not only in first quadrant but also in fourth quadrant also. So now we have two choices. One is theta can be in first quadrant or theta can be in fourth quadrant also. Then how you can decide exactly theta lies in first quadrant or exactly it is in fourth quadrant? Then you have to know about any other function which is not belonging to the same quadrant, that is other than cos theta. You have to find sin or tan or anything which is belonging to the other quadrants, because yesterday we have observed here all are positive, all in the sense sin, cos, tan, secant, etc. all trigonometric functions with acute angle they are positive, whereas here only sin positive, cosecant positive, whereas here tan positive, cot positive, and here cos and secant are positive. So this we have observed yesterday. Based on that one, secant theta 5 by 3 don't confine it is only first quadrant or it is only fourth quadrant. So other than this, let us find what about either sin, tan or cosecant, cot. To that purpose I will do now subtraction. Subtraction I will do in this way, reversal order, because minus already there, and therefore if I do subtraction, then the value you got here 2 times tan theta equal to 1 by 3 minus 3. 1 by 3 minus 3, observe here carefully, smaller number, larger number, definitely the difference is negative. Hence you got tan theta value as how much here? Negative. And secant theta value as here positive. That means tan theta negative in fourth quadrant, right? So that you can decide theta lies in fourth quadrant. Hence here we use this concept, that's why directly you have solved. One time we added and next we subtracted, thereby you got the result carefully, and thereby you decided the answer is theta in fourth quadrant. Okay. Next one, the same type of formula you are having as cosecant square theta minus cot square theta equal to 1. Then cosecant theta minus cot theta is the same as 1 divided by cosecant theta plus cot theta. This we observed in previous session, this identity, and this is true for all theta belongs to R except integral multiples of 180 degrees. And now here cosecant minus cot, you can write 1 by cosecant plus cot and vice versa. That is, these two factors are reciprocals of one another. Then how they can ask problems based on this one? Suppose, that is, if cosecant theta plus cot theta given as 2 by 3. Then they will ask about what is the answer for cos theta. Understand, cosecant theta plus cot theta, if it is 2 by 3, then what is the value of cos theta? In the same manner we start, immediately we write cosecant minus cot is how much here? 3 divided by 2. Then I add these two values, so thereby you got 2 times cosecant theta is 2 by 3 plus 3 by 2. So what is our answer? 4 plus 9, that is 13 divided by 6, and hence cosecant theta equal to, it is 13 divided by 12. 2 goes down and thereby you got 13 by 12. Again here don't confine immediately, don't start, this is positive and I know right angle triangle, hypotenuse, opposite side and thereby adjacent side will be 5, so that cos theta is nothing but 5 by 13. If you write in this way, then options they give in problem as, one option is 5 divided by 13. You observe very carefully all these problems, whatever you are getting, mains level or advanced level, many of them are having here negative marking also. And options also they frame in such a way that where exactly student can commit mistake, that kind of options also they used to give. So you should be very careful before you bubble one of the options, very carefully, diligently you have to go. And now cosecant theta 13 by 12, don't stop the problem here itself, immediately don't draw right angle triangle and thereby don't decide this is one of the answers. Okay, so what I have to do, just like the previous one, you need to subtract and you have to decide exactly what is the quadrant of theta, just like our previous problem. Cosecant theta I got positive, that doesn't mean theta is acute. So where the theta can be? It can be in first quadrant or it can be in second quadrant. So what I have to do is, I should find other function other than sine, cosecant. You find either tan or cos or their reciprocal values. So here which is easy to us, just I will take cot, that means just like our previous problem I do now subtraction. If I do subtraction, then what will happen? This is 2 times cot theta equal to 2 by 3 minus 3 by 2. Now what happened here? 2 by 3 minus 3 by 2, 2 by 3 is less than 1, 3 by 2 is more than 1. Obviously you got here negative value. So what is my confirmation now? The confirmation is theta here belonging to exactly second quadrant. So in second quadrant cos theta is what here? Negative, as theta is belonging to here second quadrant. So theta is in second quadrant implies cos theta negative. Hence what is my answer? Now you just take right angle triangle, this is theta, suppose 13 here, hypotenuse 12 here, opposite side and this is 5. So the answer is minus 5 by 13. So in exam they give like this, one is this answer and option B they give minus 5 by 13 and option C they give more here plus or minus 5 by 13 also will be given. See everywhere they are using only two numbers, what are they? 5, 13, that's it. One time they are giving plus, one time they are giving minus, then next they are giving here plus or minus. So in this way they confuse with options in JEE main and advanced level. So you should be very carefully and you have to tackle the problem in a diligent way. Now what is my final answer? Minus 5 by 13, because this is negative, whatever the value theta here, that means here 12, 13, it is 5 only, no doubt in that one, but the answer you got how much here? Minus 5 by 13. So what is the basic starting model here? The starting procedure you got here cosecant plus cot 2 by 3. They asked you about cos theta and perfect answer you have to get. So directly by using this formula you got the perfect answer. Understand students? Next one is tan square theta minus sine square theta. This is equal to tan square theta into sin square theta. This one you observe difference of two terms is same as product of the two terms. Same value, not new values, tan square theta minus sin square theta, tan square theta into sin square theta. Same values, the difference, that means here first one is t and next one is s, and then here product of those two terms. And this also many times we come across in our problems. Then how you got from this one to this answer? Then I can take, suppose LHS, left hand side if you take, tan square theta means you know sin square divided by cos square, and minus this is sin square. Now I will take sin square by cos square common. So this value 1 minus cos square. Observe carefully here, cos square into sin square by cos square, and thereby you will get again this term. Got it? And therefore this sin square by cos square means we know tan square, and 1 minus cos square means the value is here sin square theta. So you got tan square minus sin square is nothing but tan square theta into sin square theta. Okay, then where it will be useful again? Suppose if I take tan theta plus sin theta equal to some value m given, and next tan theta minus sin theta equal to n given. Understand? Then the question they will ask about m square minus n square whole square. What is this value? Okay. Now when they ask about this term, then I will find here, first take this one, m square means tan plus sin whole square minus n square tan minus sin whole square. Okay. So I have taken m square, m represents this value, n represents this value. So I took m as tan plus sin whole square minus n as tan minus sin whole square. Just now we observed some algebra formulae, that is a plus b whole square minus a minus b whole square. So dear students, I think you are understanding the importance of those algebra formulae. So now we can make use this as 4 times tan theta into sin theta. This value is only I am taking here m square minus n square. Question is what here? What is the value of m square minus n square whole square? This is the question. So I started with m square minus n square, and thereby you got 4 tan sin. But this is not in our options. The options they give in terms of product. The options they give as 4 times mn, 16 times mn, or this one is 2 times mn. In this way the options are given. So once options are given in this way, you should go in a careful way. That means your answer must be in terms of product of m and n. Now I got this value, but we require whole square is there. So I start m square minus n square whole square equal to 16 times tan square into sin square. Now tan square into sin square is nothing but what? Tan square minus sin square. So I write 16 times tan square minus sin square, that is 16 times tan plus sin into tan minus sin, and those are nothing but m into n. So we got 16 times mn. So now this is very easily we solved because you know about this identity. Otherwise you need 1 or 2 more steps extra. So just to reduce number of steps, we are using different weapons, and those are these kind of identities. Not only for 1 or 2 problems you are going to use this. Why I gave or I am giving this kind of identities, the use is, I already told you, not only for this chapter, they will be applicable many other, especially in calculus we apply many times. That's the reason you have to remember this kind of new identities also. Another one in the same way, it is cot square theta minus cos square theta. The difference again you observe, this is the difference and this is equal to cot square theta into cos square theta. These identity again you observe not for all real numbers. Here actually all the real numbers, whereas here confined to only some real numbers except all integral multiples of 180 degrees. So common value you can make use as all the real numbers except the integral multiples of 180 degrees. Now this is one more model. The previous you got here exactly. This is cotangent and that one is tangent. This is cosine, that is sine. So it is easy to you remember tangent square, and this one is here cotangent square, okay, minus sine square, and this one is cosine square. So what you have taken extra? Co again, okay. So those are tangent sine. Now cotangent cosine. So now here if I write this one again, LHS if I take, cot square theta means cos square theta divided by sine square minus cos square. Now again I will take, instead of taking cos square common, let us take cos square divided by sine square common. So you got here 1 minus how much? Sine square. Now you multiply cos square divided by sine square minus this into this, sine square get cancelled, and thereby you got cos square again. So this value is cot square theta 1 minus sine square, it is nothing but cos square theta. So this is the importance of the formula, that is cot square minus cos square, difference of these two values same as here, product of those two values. In the same way another identity also there, that is cosecant square theta plus secant square theta equal to product, that is cosecant square theta into secant square theta. Observe in those two previous formulae, in the middle we are having minus symbol, whereas now here you are having plus symbol. Those two are tangent sine, cotangent cosine. Now these are ant means cosecant, understand, cosecant, and this one is secant. So remember like this. So some values you have to remember, that means cosecant square plus secant square equal to this one. And how you got, if I take suppose LHS, that is cosecant square, we observed in the previous session, it is nothing but 1 divided by sine square, and next secant square, it is nothing but 1 divided by cos square. Now let us take LCM, that is cos square theta plus sine square theta divided by sine square theta into cos square theta. And again you know the numerator. What is the numerator? 1. So I am writing this as 1 divided by sine square theta into cos square theta. So it is 1 by sine square and into 1 by cos square. So what is the answer? Cosecant square theta into how much? Secant square theta. This one many times they give in the concept of even quadratic equations and expressions also. There they used to give us sum of the roots equal to product of the roots. Here they give us difference of the roots equal to product of the roots. That is why I have been telling you these formulae, whatever you are learning, not only confined to trigonometry but other chapters also. So let us take next one. If a sin theta plus b cos theta equal to c, then what is the value of, I am just taking reverse, that is b sin theta minus a cos theta, what is this value? Okay. So this also many times we require direct formula you can derive now. I am taking this value as suppose k, this is the requirement. Now I am taking b sin theta minus, okay, a cos theta equal to k. So let this value be k. Then given value is a sin theta plus b cos theta equal to c. Now let us do square and add. Then sin square theta into a square plus b square. plus cos square theta into a square plus b square. After that you will get minus 2ab sin cos plus 2ab sin cos. Those two get cancelled, thereby you will get here a square, that is here b square sin square plus a square sin square common. So a square plus b square equal to k square plus c square. Now what is the requirement? K. So k equal to plus or minus under root of a square plus b square minus c square. Sometimes they give this value and they will ask about this value. Then also nothing to worry, you can find the other value also, that is c square equal to plus or minus under root of a square plus b square minus k square. For example, if I give 3 sin theta minus 4 cos theta equal to some value L. Okay. Now this is L given. Now the question I can ask as 4 sin theta plus 3 cos theta equal to how much? Okay. So what I did here, just the constant terms whatever they are there, I just made ulta, reverse, and then symbol also we have changed. Then what is the formula? This is the requirement. Suppose it is our k, then k is plus or minus under root of 16 plus 9 and minus how much we can write? L square. So it is plus or minus under root of 25 minus L square. So nothing to worry, you no need of doing complete procedure and directly you apply. And here also you observe one technique, directly I took this step. Why? Because you don't use in the middle of the problems a minus b whole square completely, a square plus b square minus 2ab, a square plus b square plus 2ab, after that cancellation, after that taking common. These are all unnecessary, moreover time waste. That's why try to adopt this kind of some problems, not all, try to take direct step, a square plus b square common, again common, so sin square plus cos square. Try to use one step in the mind, one step on the paper, then only you can do problems very effectively in the given particular time. Okay students, so today what we have done is some algebra formulae, and those algebra formulae, those are not only important for this chapter, I have been telling again, they are important for coming chapters also. After that we extended those other than those 3 identities. Those extension identities, what are they actually? Cos power 4 plus sin power 4, cos power 6 minus sin power 6, and next one is secant plus tan, secant minus tan, one is reciprocal of the other. Cosecant plus cot, cosecant minus cot, one is reciprocal of the other. After that again we got difference of 2 terms, tan sin combination, cot secant, cot cos combination, you got again product of the terms. And later we got cosecant and suppose you take secant, sum of squares equal to product of those values. Finally we got this value. So students, just go through this session carefully, practice once again. Tomorrow we will be coming with again more good examples which are exactly in mains level as well as advanced level. Thank you.